Hello. So today we will discuss about idea on which you can do your uh, project or PhD research, or you can do it as an uh, internship. This is a project idea which is contemporary, useful, and from some of the most popular problems that we are dealing with presently. The title of the project is Coastal Salinity Measurement Device. Selection of location for sensor arrangement. The main objective of this internship is, or this project idea is, that you have to find the most optimal locations for a group of sensors that will constantly monitor the salinity of a coastal sea water. Why this is important is because of various factors. For example, for example, for example, coastal zones are nowadays subject to fluctuations in salinity caused by tides, precipitation, river discharge, and anthropogenic factors. Now, although the first uh, three factors are impacting the salinity of coastal water for a long time, but the anthropogenic factors, these factors, the last one, the impact of this last factor was moderate or minimum in the last decade or last century. But currently, in recent years, the impact of anthropogenic factors are the maximum, which impact the salinity of coastal zones. Because in most of the places in the world, coasts are now used as a tourist attraction, where resorts, hotels, restaurants were opened. Lots of uh, water games has been launched in the coastal region. These are not new. They were present in, suppose, in the last 50 years or 100 years also. But the impact and intensity of these activities has increased manifold. Without any regulations in place, they have uncontrollably rised in the recent years. As a result, contaminants from these installation, that means the hotels, restaurants, your resorts, homestays, and also from the games or various water games that we play there, various water rides that we uh, enjoy whenever we go to a coastal area. All of them are contaminating the seawater with organic as well as inorganic wastes, right? So these are contributing to the fluctuation or rapid fluctuations in water salinity of nearly most of the, or I would say nearly all of the coastal regions. So there's a need, urgent need for monitoring this salinity, right? Otherwise, uh, the salinity will contaminate or intrude into the land, which it is doing in many places in the Indian Peninsula and also in the UK Peninsula, not Peninsula, UK coast, American coast, African coast. So most of the coastal zones which are near to a urban settlement is more prone to this type of vulnerabilities. And if we do not monitor the salinity of coastal water, then these type of saline water intrusions, these type of vulnerabilities will slowly but steadily impact the surface water also. Surface water means the river water, pond water, etc. So we must monitor the salinity of the coastal water, and if the salinity is increasing beyond the highest limit, then we can take mitigative efforts to reduce that salinity, and thereby we will ensure that this saline water cannot intrude the mainland by contaminating the groundwater or even surface water nearby. Okay, so that is why the constant monitoring of the saline water is important. Another thing is very important is not only single point monitoring, you require multi-point monitoring, because the impact of all these factors that I have discussed, especially anthropogenic factors, varies with location in the same coast line. Okay, so in the same coastline, if you say, if this is a coastline, then the same coastline there might be very scarcer population in some place, very dense population in some area, moderate population in some other areas. So in a single coastal region, the coastal inhabitants number and density of even inhabitants may vary widely. The number of installations may vary widely. Okay? And nowadays, this recent technological advancements has ensured that compact sensor systems can be utilized. You can place the sensors here. Sensors which I mean probe, the salinity measuring probe in these places, and all these probe can be monitored from a control center nearby or even far away through internet, or if nearby through Wi-Fi connections. Okay, so this is these sensor arrangement decisions are really important also, because these multi-points salinity measurement arrangements through multiple sensors will ensure that we can estimate the salinity gradients also, not only the salinity of water but also the salinity gradient that exists in between locations, because in some places there is low salinity, in some places there are high salinity. So flow of uh, flow of salts and other contaminant, contaminations will occur between the high and low points of salinity. Even some scientists are using these gradients to generate power also. Yes, some scientists are using these gradients, salinity gradients, to generate renewable energy. You can search the net for this type of works. Okay, so but we also have to think about the cost of this entire arrangement to be installed, the manpower requirement, the complexities of the computational arrangements that is required here. So all these factors also be spatially evaluated before deciding on the locations where we can place these sensors, not only one location, in multiple locations. This entire arrangement need a solid and objective decision making approach. Okay, so you know, uh, as I have already said, decision making support reliable site specific data allows for informed decisions regarding coastal resource management, infrastructure planning, and hazard mitigation. As I have said, you can not only the management, not only the salinity, but with the help of this salinity, actually, we will manage the infrastructure that can be developed there. If there are increased in salinity, if there are uh, hazard due to salinity of water, then how to mitigate them and how we can manage the coastal resources. So that is why we require an objective way approach to identify the location of sensor placement. Okay, so this is extremely important because a sensor arrangement in optimal location will ensure optimal and universal monitoring, which will ensure proper problem identification, and also this will ensure the implementation of mitigative efforts, right? So all are interlinked. So a simple decision making architecture, if we can develop for objective selection of location, for installation of sensors which will monitor the salinity of coastal water, right, in strategic locations, right, then it will improve the data quality, the data accessibility, and data analysis ability for a intelligent and optimal decision making. Okay, so that is why this internship or this idea for research internship or project will only deal with the development of an optimal ideal methodology to put the sensors in place and help them to monitor the salinity of the coastal water. Okay, so how you can do it, right? We can do it now with the help of either MCDM techniques or bio-inspired optimization technique. By MCDM technique, you can use HP, you can use ANP, you can use Electray, you can use Promethi, multiple methods are there in here. Yes. The full form of MCDM is multi-criteria decision making, and all these methods are multi-criteria decision making methods. Anyone, not only these four, there are multiple methods. And also you can use bio-inspired optimization technique like genetic algorithm, ANN, or ant colony optimization, etc. to find the optimal locations. Okay, and what should be the proposed methodology? You have to first select the criteria, then select the alternative. These alternative can also be referred as factors, parameters, right? And then you have to apply this aggregation method as recommended by the different methods. And then you have to analyze the decision making with the help of different evaluation metrics like Fibonacci number, then your relative sensitivity of the MCDM decisions, right? Kappa, kappa coefficient, right? So there are various ways you can evaluate the decision making. What the decision has been given by the MCDM technique or optimization method, you can evaluate it with the help of kappa, Fibonacci number, Spearman coefficient, right? There are multiple of them available. Now, if you say what should be the criteria of this decision making process, then one of the main thing is that cost. Second is the whatever data you are, whatever the factor you are selecting, their data must be well accessible and available. This is also important. And third is uh, environmental factors, environmental criteria, and also environmental criteria means I want to say environmental constraints and technological constraints also. You cannot select any sensor to be installed in a coastal region. Depending upon the logistic, depending on the technological capability, these will vary. Same for this, any sensor, if it damage environment, you cannot install them. So we have to think about the environmental constraints or impacts on the sensors also, right? And another thing is that the hydrodynamic consideration means cost consideration, data accessible availability, hydrodynamic consideration of the locations, environmental constraints of the locations as well as the sensors, means you have to select a location which is environmentally insensitive. If it is very much environmentally sensitive, you cannot install anything on that because there are laws which protect that. You cannot destroy a plantation for installing your system in a coast or wherever it may be, right? So this thing must be considered. Technological constraint, I have already said the location you are installing the sensor, that sensor must be capable to monitor that type of salinity. Okay, so this is very important consideration. By alternative factors parameters, what you have to select is of course there are multiple parameters you can select. I am just giving some example. Your parameter can be distance of the location. These alternative parameters will actually evaluate the locations for its suitability for installing sensors. Okay, so distance of the location from the nearest city, because this is an important thing. Distance of the location from nearest power source, right? Then the location can be of how much tidal effect is there, because more the tidal effect, more suitable will be the location, because there only the salinity gradients get produced, and salinity varies widely. During tide, salinity increases. During ebb, salinity decreases. So tidally active regions, tidally active or not, this is the factor. Then whether nearest to confluence of river and sea, nearest to the confluence point between the sea and river, because that is where also salinity gradient exists. Okay, precipitation, how much precipitation take place in that location, that particular location. That is also can be another factor. So there can be multiple factors. You can take 50 odd, 60 odd factor, but less the factor, it is better. But also less means we are compromising quality. More means we are increasing the quality, but requirement of data becomes huge, and also requirement of computational architecture which can process this amount of data also get increased. So this is the once the decision tree you develop means this is the goal. Goal means to select the location for sensor installation. Now you'll use some criteria to evaluate this location with respect to the goal, your goal, whether this location can be used for sensor installation or not. For that, you are using this hydrodynamic activity of that location, cost for installing in that location, data accessibility and availability, environmental constraints, technological constraint, etc. After then it comes alternative or factors. Okay, so with the help of each of these factors, actually the locations will be evaluated for its suitability in installing a sensor on that location. Okay, so these factors can be many things: distance nearest to city, distance from power source, tidally active or not, confluence point or not, how much precipitation is there, and various other different factors can be used. Now, to decide which factor is how much important with respect to this goal, each of these criteria will be used to compare each of these alternative. Okay, and then the resultant weightage of importance for each of these alternative will be decided, and with the help of that you can create a index which can be equals to Wm multiplied by the magnitude of the factors divided by the Wm, right? So this W is the weightage of this factor and Fm is the magnitude of the factor. This is the summation of all this weightage used for all the factors. Generally it is equals to 1, and this weightage will be defined or determined by the MCDM technique that I discussed. Application of aggregation methods. Okay, these aggregation methods mean HP method, ANP method, electric method, etc. If you are using MCDM technique, and if you are using bioinspired optimization technique, then what happen is then this index become the your objective function. W becomes the design variable. Fm become the magnitude of the factors for a certain location, and then if you divide it like this, and if you vary Wm from 0 to 1, then the point at which y become maximum becomes the optimal weightage of the optimal or the point at which y become maximum, because suitability, this is more this indicator, this this means this indicator I is directly proportional to the suitability of location for sensor placement, and more this indicator value of indicator, more suitable the location is for installing a sensor. So as a result, if I maximize this equation by changing this Wm, because Fm is fixed for a certain location, so if I do that, then at the optimal point this value of weightage will give me the value of y, the highest y. So that means if a location has the magnitude in in a way that this indicator value becomes maximum, then that location is most suitable for installing a sensor. That is the logic. Okay, and that can be indicated by if you find that FM has the weightage as determined by the optimization WMM, which has the highest value among all the weightage. So FM must be very high such that the Y become high also, because WM is already high. So that location which has the highest value of the factor which has the highest weightage will automatically become the most suitable location. So in this way you can identify the locations one by one for the suitability of sensor placement. Another issue is that once we have done that, the decision of identifying this alternative as the best and worst can be analyzed with these evaluation metrics: kappa, F1, Spearman. All these are evaluation metrics which are used when rank instead of magnitude of the parameters are utilized. In this case also, you will get the weightage of importance of A1, A2, A3, A4, A5, which can be used to rank each of these alternatives. Now, you are using AHP once, then use ANP, then use electric, then use Promethe. So you have four results. So four different weightage of these alternatives. Which one is most nearest? For that, you can use kappa, F1, etc. metrics. Okay, so the decision which is the most nearest can be selected as the optimal decision. So this is just an idea of that research objective. We have to develop it more. We have to develop it. We have to think about it more. And if you are serious about doing a project, you can do a project like this because of the requirement of monitoring coastal salinity to avoid contamination of groundwater and as well as surface water in coastal regions. So if you are interested to do this as an internship, you can contact with me by commenting. Otherwise, you can analyze or nurture this idea with your guide, and you can use this idea for your project, for your internship, or for your PhD research. Thank you for now. See you in the next presentation or video. And this video will be available in my newsletter hydrogeek.substack.com. So if you visit that and subscribe, you will find this video and more similar videos you can identify there. Thank you, and I will finish now. If you like this video, then like, subscribe and share, and remember to press the bell icon, because if you press that bell icon, then only whenever I post something new in my YouTube channel, it will show in your subscription feed. So goodbye for now. See you in the next